All right, today chemistry, we're going to do a couple of examples of acid-base titrations, and it's typically very simple because the molar ratios never get out of whack. All right, so pretty long setup here. We'll go through it. A student performs a titration by first preparing 40 mils of sodium hydroxide. The hydroxide concentration is half a mole per liter. Then hydrochloric acid is slowly added. We turn bromothymol blue green. Check this out. We'll get into this later, but I'll show it to you now. In your data booklet, near the back, there's a list of indicators. Okay, bromothymol blue is really common. This column is the pH range. That's when there's a color change. Okay, so between 6 and 7.6, which is right around neutral pH of 7. That's what makes this such a good indicator for acid-base titrations of strong acid, strong base. We'll get into how to tell the pH at equivalence point later, but a strong acid, strong base equivalence point is always pH 7. So that's within the bromothymol blue pH range, which makes it a great indicator for strong acid, strong base. All right. They color change from yellow to blue, so if it's green, you know you're right in the sweet spot of the equivalence point. Right? So that's what this sentence is all about. It's just telling you that the titration was performed correctly, that the end point is right where you want it, right near the equivalence point. Okay, so at that end point, the student had added 88 mils of the hydrochloric acid. We are going to determine its concentration. All right? So like I've mentioned, these aren't nearly as involved as redox titrations. They're usually pretty nice. Okay? HCl is a strong acid, so it just ionizes in water. It's just H3O. All right. It's going to react with the hydroxide to form water. Right? The molar ratio of hydroxide to hydronium is 1:1. All right. So the equivalence point will occur when there's equal number of moles here. We can find the number of moles of hydroxide really, really simply. Okay. It's just the concentration times the volume. Concentration is half a mole per liter. The volume is 40 mils. I'm going to put that into the liters by dividing by 1,000. Okay, so this is going to be 0.02 moles of hydroxide. Okay, but that's going to equal the number of moles of hydronium. Okay, now we can combine this with the volume we've added to get the concentration of hydronium, which, I might as well get that out of the way, is the concentration of hydrochloric acid because it ionizes quantitatively. Nothing tricky going on here. All right, so we just have to do the number of moles divided by the volume to get concentration. Number of moles is equal to the hydroxide moles. Volume's up here. Okay, let's see what we get. Okay, I get 0.227 moles per liter. Looks good.